Hi everyone, welcome back to the course. Today we are diving into three powerful functional programming concepts: recursive function, carrying, and the function compositions. These techniques might seem advanced, but they are going to transform the way you thinking about writing functions. So let's get started. The first is recursive functions. So let's start with the recursion. A recursive function is simply a function that calls itself. Okay. Now I know that sounds weird at first, but it's incredibly useful for solving problems that can be broken down into a smaller, similar problems. Okay. Every recursive function needs two things: a base case and the recursive case. The base case is where the function stops calling itself. Without it, you did have an infinite loop. And the recursive case is where the function calls itself with modify the argument. So let's look at a classic example for the calculating the factorial. You see, so when we call this factorial, it's return 5 into the factorial 4 first. Okay, then which returns 4 into factorials 3. So and so on until we hit our base case. Then all those multiplications happens and we got we got the 120, the actual output. Okay, so how it's happening? When you are passing the value, the factorial, I mean this argument here, you see, if n triple equal is 0 or n equal 1, then return 1. If not, then recursive this factory, this function itself. So how it works? N is initial 5, then this calling this n again n minus 1. That means it's 4 minus 5 minus 5 into the initially, if it's a 5, then it's get the 4. Okay, then 4 it's get 3, like that. Okay, let's try the another example, like counting down. Suppose like this, the countdown function. Okay, do you see the parameter? If this parameter, I mean the num less than 0, then nothing return, empty return without anything. Otherwise you get the answer. And how it look like? You see 5 4 3 2 1 countdown itself. Okay, it's always give you the uh, decrement value. Okay, so you get this answer. When it's 0, it's automatically stop here with the empty returns. So here's a more practical example, like summing an array. I mean sum an array recursively. Suppose you see sum array, and in this array dot length, if the equal is 0, then return only 0. If not, then the actual recursive are happening here. Like initial array index 0, then plus with this array, then slice by 1, and you get this output all together. This is an array, and you get the all equal summation result here, 15. Okay. Okay, great. So okay, one more example, like the flattening a nested array. Okay, like you see, this code uses the recursion to turn any deeply nested array into a straight list of value. So what it does, it works through each item into an input array. If the item is itself an array, it flattens that sub array first and then merges its merges the contents. If the item is a value like number, a string, or etc., it add it directly to the result. Now, how it works step by step? Initially, it started with the empty result array, right? Then loop through loop through the every each item in array, then checking is the item an array. If yes, then call the flattens itself here again, and this is the recursive step. Okay, then concatenate those flattened items into result here. Do you see the concat this result here itself? Sorry. So if no, then push the item into the result. Okay, then the return result once all item are processed. Okay, great. Next question. Actually, next is the recursion is powerful. Okay, so but be careful. Too many recursive calls can cause a stack overflow error. For for very large data sets, iterative solution might be a better. Okay, next section, actually next topic is our carrying. The carrying is a technique where you transform a function that takes multiple arguments into a sequence of functions that each take a single argument. Instead of calling a function like the function name is add, the parameter is, or I mean, you passing the argument 2 or 3. With the carrying, you did call it like parenthesis, the single parenthesis for both, right? 2 and 3. I mean, actually each function call returns another function until all arguments are provided. Let's see the simple example first. So it would be very good for understanding. You see, this is the add function. It's written actually this add function has a 3 parameter. When you are calling with this is a regular function, okay? The add 2, 3, 4. But in carry, I mean the carrying version is A, remember A, then return B, then return C. Did you notice? This return actually execute the function, callback function, then this function again return another execution, another function. So then return the A, B, C. When you are console log this, you are calling it differently like this. We can write this more consciously with the arrow function. This is the simple traditional method, but we can do the same thing with the arrow function like this. Just this. This is an array. This the first arrow function, second arrow, and third arrow function. Okay, and this code is much cleaner. So why would you use the carrying? It allow you to create specialized functions from general ones. Okay, so let's check this out. Multiply, then double, then triple. Did you notice this multiply 2 times, it multiply 3 times, and you got the answer is like when you are double using this function, then you get 5 as a 2 times, and square it's actually multiply the square, and this was the triple. Okay, and 10 and 15, and great. So here is the another practical example with the grading function. This is grade. This is an arrow function. This is another array function, then return this both, I mean the greeting and name. And when you are saying the hello, greet hello and goodbye, you see this hello, say hello is Alice, with say hello it's return this hello and then Alice name. Notice something? Because the first is this, second is this. Okay, I mean first is this, second is this. It's printed the both. Okay, great. So let's take the another real world example, like the creating a discount function. Okay, creating a discount function. Suppose this. Okay, this is the function, and you get this. Okay, so what the function is this actually discount is a carry function. It takes one input at a time. The first input is discount percent is 10, and it's return a new function that expect the second input, like the price is 100 here. Okay, that inner function calculate the price, like the price into discount percentage here, price into discount percentage, then divided by 100. I mean, the subtract the discount. Okay, actually, why the carrying helps here? By fixing the discount percentage once, you get the specialized function you can reuse. Okay, like 10% off. Okay, this 10% off. So what is this 10%? What it does? The discount is 10. Create a function that always apply for 10%. Okay, then this is another 20% off. This 20% creates a function that always apply for 20. Right? Using this presents, actually sorry, using these presets. So how it does, like if you are using the 10% off, this 10%, so it what it does, actually it doing like this 100, not here, 100 minus, then 100 into 10 slash 100 equal 90. I hope you got this answer. Exactly same thing happening here, like 100 minus 100 into 20 divided by 100, then equal 80. Okay, Great job. I hope you understood the recursion. Okay. You can also create a generic carry, carrying function that can carry any function. Okay, like this. This helper turned any multi-argument function into a chain of single argument calls. Okay. Actually, how what carry does? You give a carry a normal function like this fn. Okay, this fn, and like this sum. Okay, just an example, sum function. Okay, it turns a new function carried that collect arguments across calls. Okay, once the total collected arguments count reach the fn dot length, this length, the argument, this length, the fn dot length. Okay, the number of the parameter of fn expected, right? It's called fn with all of them and return the result, this result, right? Sorry, this result, and this is the else if it's not true. So how the code work actually? This fn dot length, one kind of is for sum. There's the three. Actually, that's three because it has a three parameter. It has a three parameter, right? So carry the argument. This function first call the collect sum argument. Actually, first of all, first call it's collect the all the arguments. The sum arguments. Okay. So if args dot length, if args dot length greater than equal fn dot length, then call fn this the return this function argument immediately. Otherwise, return another function that collects more this next argument. Okay, and you get the another result. This another function that collects more, right? The next this this rest operator, three dots, and the next arguments. Okay, then the equal, the arrow function, what it does, it's return the carried this function with this parameter, sorry, argument, with this argument. Okay, great. Actually, this create a chain where each call adds more argument until there are enough. Okay, great example. This is one of the best example for carrying. I hope you got understood. And this is complicated and advanced concept in JavaScript. So please pause the video again and again, practice more and more, try to understand what I say. Okay, now finally let's talk about the function composition. This is where you combine multiple functions to create a new function. The output of one function becomes the input of the next. Think of it like the pipeline. Data flows through one function, then the result flow through the next function, and so on. So here is the example. Okay, you see, this is function 1, 2, 3, all are arrow function. Then you notice this, and this is the manual composition. What it does, the subtract to then call the multiply, right? Because it's collect the function and call this function again, and you see, and then you get the result. And the result, how it look like, the 43, 10 plus 5 equal 15. First, second, 15 into 3. Remember here, it would be a 45. Then 45 minus 2. This, you see, this is the first function. This is the second function. This is our third function. So it call immediately first. Then it one. Then it one, and you get 43. Okay. So, but reading nested function calls from right to left is confusing. So let's create a compose function. This is a compose function, and this arrow function, what it takes as a parameter, rest of the function as a parameter. Okay, that means you can pass multiple function without putting manually the function name. Okay, so see, then it's return a value. This is another function. Then then return this return a functions which reduce the right. And what it does, it's take two parameter. First is the this function. This first parameter are putting here as a function call, and then get the value from this return. And when you are composite, and you get the exactly same result. calculate 10, you get exact same result what you are doing here. Actually, what you does here, and you get exactly same thing here. Actually, we can also create a pipe function that run function left to right instead if we want to. Okay, suppose this one, this pipes. Okay, this function actually, how the code actually does, what the code does here. This pipe function actually get the functions rest of the function rest function, and then as a parameter return a new function, right? Return a new function that expect an initial value, right? Initial value inside reduce process the list of function in order, list of function in order. Okay, start with the initial value, and then for each fn, okay, and compute the fn with the SCC and use that as the new SCC. Okay, new SCC. When all the functions finish, then return the final SCC here. This was this here. Okay, great. So what it means, the given a add 5 and multiply 3 and subtract 2 and starting value is 10 here. So think start from 10, start from 10 like this. Then another is add 5, it would be a 10. Okay, then you get 15. Okay, then another is multiply 3. So it what it does, it would be a 15. This 15 it give you a 45. Then when you are subtract 2, this return the 45 and you get 43. That means the final result will be 43. I hope you understood how this function actually working. And actually, when if you are thinking just calling this function and you get the exact result, no, this function is not like that. Actually, you think this is your helper function. You are calling, I mean, you are executing this function based on your niche, and this is the based on your niche. At first, you are storing or storing the data as a value in this variable. Then you are calling this variable or calling this function with the exact number what you actually want. Okay, and this is a great example. Great example. I hope you understood. And video length already take too long, but don't worry, this is necessary. Okay, so I give you a more practical example, like the processing user data. You see, this is the processing user data. And another example is like working with the arrays, working with array. Okay, like working with arrays. And this one is user data. Okay, good, very good example. You see, you already get the output, how it actually look like, and how to execute this value. Okay, so I hope you didn't face any problem. If you are facing any types of issue, any problem, just comment your issue, and I'll give you my solution proper way. So okay, let me fix the example. Suppose another example, like think it. You see, double array, and then 1 2 3 4. Okay, not this one. Actually, they both are similar. No. This not this one. Okay, just a minute. Okay, this one. Actually, this is combining the carrying and composition together. It actually combining carrying and composition together. Okay, this is a great example. You notice, really great example. Okay, all right. So let's recap. We cover 3 powerful concepts today: recursion, the function that call themselves, and perfect for problem that can be broken down into a smaller similar problem. Okay. Second is carrying, transforming multi-argument functions into sequence of single argument functions, which helps create specialized function. Third is composition, combining multiple function into a pipeline, making your code more readable and the maintainable. Okay, so these concepts are fundamental to functional programming and will make your code more elegant and reusable. So in the next video, we'll explore the JavaScript engine, execution context, and hoisting. So see you in the next video.